Alright guys, here's are the answers in the work for the practice test. So hopefully this will help you guys get ready for the test on Monday. So make sure you get some time over this weekend to review them. Alright, so for number one, it says list the order pair shown in the mapping diagram, then determine whether relations are functions or not. So first of all, if we want to know what is a function is that when you have is a relation that for every input is assigned to one output. So a lot of you guys got confused that, oh, because the 2 is the input and the 4 is the input, and you have the same output is 9. Well, this is still a function because, again, for every input, you still have an output. Okay, so for example, let's say 2 students took the test in the first period, get a 9 point, and then 4 students in the third period also get 9 points. So even though you have 2 students in the first period and 4 students in the third period have the same score, it is still okay. So this is still a function. So this is, yes, it is a function. Yes, it is a function. It is a function because, again, because for every output, okay, it is a function. And then you can say because for every output, okay, for every input, it pairs exactly, that's the key term, exactly one output. So I can say that this is still a function. Now, if it's the other way around, so let's say if you have one input, so let's say the 2 have mapping up with the 10 and the 9 at the same time, then that is not a function because you can't have one input and have 2 outputs, okay? All right, so that is the answer to number 1. Number 2 is they draw a mapping diagram that represent the relation and then determine whether the relation is a function and make sure you explain. Okay, that's the key term here. You have to explain it. Okay, so let's see. I had the first point right there is 3, 5. So the 3 go to the 5. That's the mapping right there. Okay, and then you have -1 go to 1. -1 go to 1. And then you have -1 go to 3. -1 to 3. -1 to 3. -1 to 3. So you see how you have one input right there and you have 2 outputs. Okay, and then you have 1 positive 2. 1 positive 2. 1 positive 2. Okay, and then last point, you have 3 is the input and the output is 4. So 3 mapping up with 4. 3 mapping up with 4. So from there I can tell you that this relation is not a function because you can see how there's only one input and you have 2 different outputs. So the answer is no, it is not a function because, again, you have one input which is a -1 here. The -1 is the one input and you pair up with 2 different outputs. So I'll leave it to you guys. It's your job to type it out. It's your job to explain that out. And I gave you the answer right there. Is because there's only one input here which is -1 and you end up having 2 outputs. Okay, so it is not a function. No, it is not a function. All right, number 3, write a function rule for this rule right here. They say the output is twice the input. The output is the y. E is mean equal. Okay, twice the output is mean twice whatever the input is, which is x. You multiply it to 2. So twice the output. So your function is y equal to 2x. And I think I told you I prefer you to write it as f of x because that is a function. We use the notation f of x. F of x equal to 2x. Okay, so we replace the y by the f of x. Okay, so your answer is f of x equal 2x. Number 4, graph the function. Before I graph this function right here, I like to rewrite that in y equal mx plus b form. Okay, this is, so I'm gonna switch the 1 and the -3. Switch the orders. So your equation or your function is going to be y equal 3x plus 1. Negative 3x plus 1. Now, if you remember how to graph this using y equal mx plus b from like chapter 4 and chapter 5 that you learned, you can all do that. But if you don't remember, the first thing I would do is I'm going to construct a table. Okay, this is my x, this is my y. Okay, when x equal to 0, the best number to pick is 0. So when the input is 0, you put the 0 in for the x. Negative 3 times 0 is 0. 0 plus 1 is 1. And that is also the y-intercept, because the y-intercept is y equal mx plus b. The b is positive 1. I'm going to pick 2 more values before I plot the order pairs. The next input is going to be 1. Negative 3 times 1 is negative 3. And then negative 3 plus 1 is going to be negative 2. Okay, so that's my second order pair. And the third one I'm going to go with the input is equal to 2. Negative 3 times 2 is 6. Negative 6. Negative 6 plus 1 is negative 5. So remember I told you you're going to need at least anywhere from 3 to 4 points. Okay, so I'm going to go ahead and draw myself a coordinate plane. Look like my x is going to go from 0 to 2 and my y is going from negative 1 to negative 5. So that would be right there is my y-axis. My x-axis is going to be from 1 to 2. Alright, don't forget to label your x and your y-axis. Okay, so you're going to go positive 1, positive 2. On the y, that's positive 1. Negative 1, negative 2, negative 3, negative 4, negative 5. Alright. Okay, so 0, 1, that's my y-intercept right there. That's 0, 1. Point 0, 1 is right there. That's my y-intercept. And then positive 1, negative 2, positive 1, down negative 2. That is my second point right there. And then positive 2, negative 5. Positive 2, negative 5 is down here. And then from there, you can go ahead and connect your line. Okay, connect your line. So I'm going to connect these dots. Connect these dots to form a line. And don't forget, you always put the arrow of each end of the line. Okay, so that right there is the graph of this function y equal negative 3x plus 1. All right, number 5. Use the graph to write a linear function that relates y to x. Okay, well, first things first, always want to do is let's draw a line first. There's my line. So I can see that these points right here, the line go through all these points. All right. Okay, so from there, I'm going to go ahead. Okay, I know it's a habit, but don't forget to put the arrows on each end. Well, I look at the graph, I can see that the line crosses the y-axis at negative 0, negative 1. 0, negative 1. So therefore, my y-intercept was going to be negative 1. So y equal mx plus b, and the b is negative 1. So I'm going to put the b in here first. And then I'm going to go back to my graph. I'm going to pick 2 points on the line. I'm going to pick this point and this point. So from this point to this point, I'm going to have to rise 1 over 2, rise over run, rise 1 over 2, up 1 over 2. So again, the definition of slope is rise over run. So I'm going to go ahead and replace the 1 over 2 in for the slope. So my slope there is 1 over 2. 1 over 2 is my slope. So my equation or my function for this is y equal 1/2 x minus 1. Or you can pick the 2 points on the line and then you can use the slope formula. M equal y2 minus y1 divided by x2 minus x1. And it still is going to give you 1/2 as your slope. Okay, so that is number 5. Number 6 is say, does the table represent a linear or non-linear function? And you have to explain. Okay, well, let's take a look at this table values. If it's a linear function, then the rate of change is constant. And if the rate of change is not constant, then it's a non-linear function. So let's take a look at the rate of change to see it is constant or not by looking at the rise over run, the change in y over the change in x, to see if they are constant or not. Well, look at the input. You go from 0 to 2, you plus 2, 2 to 4, you plus 2, plus 2, 4 to 6, you plus 2, and then 8 to 0, you subtract 8, 0 to 8, to negative 8, you subtract 8, and negative 8 to negative 16, you subtract 8. So look like to me, the rate of change is constant. It look the same to me. Rise over run, they all look like the same. Negative 8 over 2, negative 8 over 2. Oh, this is supposed to be a 2 right here. Negative 8 over 2. So my slope is negative 8 over 2. And you can simplify that as negative 4. So my slope is constant, which is negative 4. So it is a linear. It is a linear function, and I'll let you explain it. Okay, and again, is a linear function because the rate of change is constant, or you have a constant rate of change. Constant rate of change. So you have to use that. You have to use that term, this term, to explain constant rate of change. Okay. Alright, that is taken care of. Number 6. I don't think I have enough time to go over all 9 problems. Especially with number 8, I think that should be easy. That's the last thing that we do. Describe the change right here by looking at the graph. For number 8, you can see the stock beginning right here. This stock B, high price, and then a decrease, and it stay constant, and an increase, stay constant. Stock A is that really low, and then it increase, stay constant, decrease, and it stay constant. So use that to answer A, B, C. Okay, for number 8. All right. Let me go back to number 7. A table shows the number of meters in Y and of a water skier travel in X minute. So X is the number of minutes, and so the first thing they want you to write a function rule relates Y to X. Okay, well, let's go find the slope first. Let's go find the rate of change. You plus 1 for every minute. Okay, it looks like the table, it goes up every minute, plus 1, plus 1. And then let's take a look at the meters. You go from 600 to 1200, that's plus 600. And then 1200 to 1800, that is plus 600. 1800 to 2400, you plus 600. And then 2400 to 3000, you plus 600. So your slope again, M is, or rate of change is rise over run, which is 600. So it changed 600 meters per minute. 600 meters per minute. So my function is going to be y equal mx plus b. Y equal mx plus b. And my slope is 600. Okay. Times x. Okay, again the slope is 600 times the input, which is the x. Now what do you think the y-intercept is in this case? Well, even though it didn't give it to me, but if it goes up every 600 meters for every minute, so if you go back to minute 0, then the meter is going to be at 0. So the y-intercept for this function is going to be 0. So it's just y equals 600 plus x plus 0, which is, so you don't have to write this 0. So your function is just going to be y equals 600 times x. And then from there you can graph the linear function. Okay, to graph this function, you have to draw your x and your y axis. Okay. Now for the minutes, you can go up to 5. 1, 2, 3, 4, 5. Now the meters, you have to go up by 600. So you can go 600. 1200, all right, 1800, 2400, and 3000. So, and then you plot the point, you connect the line, you should give you a straight line. Once you have that, the next part, it asks you to, at this rate, how many kilometers will be in the water ski in 12 minutes. So first thing first, you have to take 12 minutes and you have to plug it in to the x. However, that answer is going to give you in meters. Now I'm going to give you a hint. 1000 meters is going to equal to 1 kilometers. So you have, don't forget to convert that into kilometers, okay? And now let you guys go ahead and take care of part D. Any questions, you feel free